Finding the derivative is a very, very, very easy thing to do. What I'm going to do is I'm going to show you using another function. We're going to do another function. We're going to do the little easier function, f of x equals x squared. And what we're going to do with that is we're going to find the derivative, and then I'm going to interpret the derivative for you, and then we'll go back to our original example, and I'll show you how we find the slope. Go ahead and grab f of x equals x squared. All right. We have a parabola, and we have some points. I want you to notice that the slope is changing. Here's my slope. It starts out, and it's not very steep, is it?
No.
You understand the tangent line? And then it changes as I go up. In other words, this slope isn't as steep as this one. It starts out like this, right? This is my first slope. Between 0, 0, and 1, 1, there's my slope. And then I have another slope that's steeper, and then I have another slope that's steeper and steeper. But this is the slope through 2 points. What I want is the slope through 1 point, which is called the tangent line. Remember that from geometry? It's where it touches the curve at 1 point. Watch what happens as I move it up. Y'all imagine the tangent line? You can kind of imagine it pretty good, yeah? Can y'all see it? Does it work pretty good? Let me see. I'll put it down here. As you move up the curve, notice that the tangent line gets steeper and steeper, doesn't it? See what I mean? Now what I want to do is find the slope of the tangent line. That's going to be my velocity at any given point, or my slope at any point. I can find the slope at this point, the slope at this point, the slope at this point, or any other point I want. This happens to be a function, and it's called the derivative. We indicate it like this, f prime of x. This is called the derivative. And it's equal to the slope at any point. Sounds hard, but here's how you find the derivative. The derivative, we find it, you multiply the exponent by the coefficient, and then subtract 1 from the exponent. That's how you take derivatives. What? Sounds hard. Can someone tell me, for this function, what is the coefficient? 1. We don't see it, but it's there, isn't it? Y'all know what a coefficient is?
Yes.
The number in front of x. Okay, now I know this is really tough. You're going to have to try it. We are going to have to multiply the exponent by the coefficient. Multiply the exponent times the coefficient. What do you get?
2.
2. And then you subtract 1 from the exponent. 1. Okay. To find the derivative, we multiply the exponent, what's the exponent? 2, by the coefficient. 1, which gives us 2, and then we subtract 1 from the exponent, which gives us x to the first. That is the derivative. Now, I told you that calculus is very easy to do. Doing calculus involves multiplying 1 times 2 and subtracting 1. This is literally, this is the derivative, f prime of x. This is how you do it. Half of calculus, you're going to be finding derivatives and using them to find things. And using applications of derivatives. Now, I'm sorry? Yeah, it's 2 times 1 is 2, subtract the 1, you get 1. There it is. That's called the derivative. The derivative is the slope at any point. Let's see. What is the slope of the tangent line at this point? I'm going to put this point in green. What is this point, everybody? 1, 1. What is the slope of the tangent line at 1, 1? I'm going to draw the tangent line first. Here's my tangent line. It just touches it. Now what I want to know is, what is the slope of that green line? The slope is the derivative. 2x is the slope at any point. What's x? So what's the slope? 2. The slope of the green line is 2, because at any point, the slope is equal to the derivative. The derivative in this case is 2x, so at 1, the slope of this line is 2. Got it? Let's make sure. What is the slope at the red point? What is the red point? 2, 4. And what is the slope of the line at the red point? 2 times x. What's x? 4. So the slope is 4. 2 times 2 is 4. I substitute 2 into here, and I get 2x, which is 4. That's the slope when it goes past here. The slope equals 4. What about at the top point, at this point up here? What's this point right here? 3, 9. And what is the slope of the tangent line? 6. Because 3 times 2 is 6.